Hi everyone, welcome back to the Altium Develop series. So most hardware onboarding fails because new engineers are trained on documents, not the real designs. So they have given the access to the documents, training documents. They read their documents. Those are not updated, and they are the previous and the old documents. And maybe if they are new documents, but they may be the issue with the documents like they have no one basically reads the document PDFs. They are outdating training slides. Just copy the last designs, not the real world and the real scenarios like where should we use the impedance matching and where should the real design use the length tuning or this type of stuff. So it's basically the problem with the conventional onboarding problem in hardware teams. So let's take a simple scenario like hiring a new engineer, and we will see. Let's say we and a new engineer, junior PCB design engineer is hired, and company wants to train that engineer in the probation period, like he is a new design engineer, and our goal and the designer's goal is to understand the real world project standards and decision makings. So what tool he will use in this scenario? Let's consider he is doing obviously the Altium Develop workspace. He will be working over there and understanding the real time projects from Altium Develop workspace. So new engineers don't lack the intelligence, they basically lack the context. So why Altium Develop is ideal for training? Altium Develop is ideal for training because it has a real project, because all the projects, the real world project, who is those projects which are assembled and uh, tested from the functionality. So the if the new engineer wants to learn from the project which is already tested and in working, from the logical schematics point of view to the cosmetics point of view of the schematics, like where should we place the label and what type of the label will be, like net, it should be the net label or the local label or global label, what will be the label, and where should we add the notes, and what should be the content of the note, or what should be added, like we will see in a while in our in this video. So he can access the real history of the project, what are the basic steps when designing the PCB, how does the collaboration between the hardware design engineer and an MK design engineer plays in the Altium Develop workspace. So let's open the project and see how they basically learn from the very basic. So um, first of all, the if he wants to learn from the real world schematics into the Ultimate workspace, he just go to the workspace and assign the access to the newbie training engineer. So he can open the context of the design files like the schematics, PCB design. Like here on the first page, when he opens, he will see these references and he will get all the idea of the uh, like this register naming rules, naming rule 1, naming rule 2. Here it's written over here, example is over here, that this convention will be used throughout the schematics. Different schematics files, different schematics docs are added in this project. So wherever he will see the register value, what should be the register value and where should it written, like this value plus r plus size plus tolerance, like he will get the idea that basically the new schematics, new standards of the schematics, and how should we write the values of the component in this way. So he will get from this like value, let's say the 1k, and the r representing the register, size will be the package size, and tolerance will be the what should be the tolerance, like here it's written over here, b means plus minus 0.1%. So If we have to write every time plus minus 0.1% to the every register, it will take a lot of time. So basically, the modern way to write it over here to assign it to some alphabet, like here B is assigned to plus minus 0.1% and C in the same way. So you don't need to write again and again the value of the resistor and other stuff. In the same way, capacitor value, capacitor naming procedure is given over here. Example is over there. So he will see modern schematics design basically gives the references to the first page of the schematics. So in the whole schematics, if the new engineer comes and see what is in the whole schematics, what will be the naming convention, and other notes can also be mentioned over the first page, so he can understand. Even the reviewer can come and can see the schematics is neat and clean, and he can start doing the review. So here you can see the bad power 17 pdb is going into the connector with the tvs diode, not and the TVS diode with the ground, so it's going outside the PCB. So we can see whenever some signal is coming out from the board or going out from the board, so we basically use the TVS diode because it has some uh, surge comes, then it should be go move towards the ground. And here the studs are used for studs basically for the PCB board. They place for the mounting of the board to some enclosure or somewhere. And these are some labels, global labels. When you click over here, you can see it going into the another sheet to some ICINA series, and go back, and it's basically coming out from the board and going into this IC, SCL and SDA. Same way the SDA is going is the bidirectional. It can coming in and going out. The signal is it can be come in from the from outside of the board and go out from the board. So here another thing he can see is ESCM1. Basically, this is the bus use over here. Bus has the multiple wires in it combined over there. So you can see it's the signal coming to the different ICs through the bus. So here you can see the note under voltage lockout threshold is given with this IC. So when a new engineer see this, so he can get the idea what the circuit is about. He can go to its data sheet and can see what should be the circuit for the under voltage lockout case. And the MOSFET, two MOSFETs are connected in parallel with the common gate. So it's for the ORing purpose. As you are saying, we are seeing these schematics. I am also seeing these schematics for the first time, so I'm getting a clear idea of what the schematics is about. So if the new engineer can come, so he can also see what the schematics is. So he don't need to know the logic of the circuit. He can just understand first the principles of designing the circuit and the PCB. As in the PCB, in the same way, the PCB, the connector is the connector. As you can see, it's highlighted, and you can see in the schematics where it is, and you can analyze where the connectors are basically used. These connectors basically used at the uh, boundaries of the board. So in this way you can analyze the schematics and understand the basic principles of designing the schematics and the PCB. So we have seen that the how Altium Develop is helpful for the newly hired engineer, and how the company can train its engineer from the real world projects, and what should be the standards of its company for the schematics and PCB. Those basic principle which a hardware design engineer should know. So that's all for today's video. Thanks for watching and follow us for the upcoming videos.